Welcome back everyone. Am I audible properly? Those who are joining online, okay. So yesterday we left the class on transaction, right? So let's discuss what is a transaction and how can we best define this word transaction.
This meeting is being recorded.
Transaction. Okay. So yesterday also we have seen something that transaction is a process or you can say a single unit of work where values will change so that is called a transaction. So here we can say that transaction can be defined as a single unit of work which consists of one or more operations. There can be more than one operation in one transaction. In terms of database, we can say that create, update, or you can say read, update, and delete are the transaction where read operation is not a true transaction. It is not a true transaction because in reading the data, the values will not change. The values will not change. You know, there is a property of transaction. The property is, let's say you are writing a query for a table. This is your table with 3 columns. This is your table with 3 columns. First column is for ID, second is for name, and third is for email. If you want to insert the data in this table, So we can write a query like this, that insert into student, insert into student. Amar, check your internet connection. Here we'll say insert into student values ID 1, name Shrikar, and email shrikar at the rate of gmail.com. Now this is the wrong query, right? If I am writing the query in this format, it is a wrong query, right, Shrikar? It's a wrong query. Sorry. Yes. Email is also a string. That's what I'm saying. This is a wrong query. And you pressed enter, or means you executed this query. First column is for ID. One will go there. Second column is for name. Shrikar will go there. Third column is for email. And email requires a string value. And what we are providing here, we are providing with a normal object value, or you can say numeric value. It should be a string. Now, when this query is executing, it will give us a result in this format. ID1 will come here and Shrikar will come here, and in email nothing will come, right? Right? Is it possible that half values of a query are stored and half are not stored? These two values are getting stored into the table, and this email value is not going into the table. Is it possible? No, it's not possible. So for transaction, we say the same thing, that there is an important property attached to the transaction. Either it will be committed fully, either it will be committed fully or not at all. There is no middle way here, that half values are stored, half will not store. No, not at all. Either all will be going into the database or table, or not even a single value will go. For an example, let us consider we have a table of student with ID column, name column, and email column. So we have these three columns. Okay, we have these three columns. And let's first write this only. So this is the table that we are talking about. This is the student table. We are writing a query to insert one student's data, and the query that we are writing is looking like this. Now in this query, in the above written query, there is a syntax error. There is a syntax error. Email value, or you can say we should provide email value as a string, but we are not providing it. In this case, database will not store one as ID and Shrikar as name of student. It will not store these two values also. There is a property about transaction that either it will committed fully or not at all. Either it will commit fully or not at all. And where is it used? So let's say you are trying to order a particular product for you, and for ordering that product cash on delivery is not applicable, means you have to make the prepaid payment, means at first you have to pay, then only you will get the confirmation. Now there will be one property attached to it, and that property is, if you are making payment, then only product will be getting ordered, otherwise no. So these kind of processes are called transaction consistency. That transaction is consistent. So this is called a transaction. This is called a transaction. Now again, here you have lot of databases where you can perform the transaction. You have RDBMS, DBMS. In that you have Oracle, MySQL, PostgreSQL, Cassandra, lot are there. H2 is there and MongoDB is there. So like that you will say these are the transaction. Or else let me give you one more scenario. You went to an ATM machine to withdraw some cash. ATM machine, and in the ATM machine currently 20,000 rupee cash is available. In the ATM machine 20,000 rupees cash is available. So now it is known fact that you can only withdraw up to 20,000. By the way, it is hidden. It is not visible to user. What user is doing? User is trying to withdraw 21,000. Now ATM machine will not say that, okay, okay, now I am giving you 20,000, 1,000 you take next time. No. Either transaction will be committed fully or not at all. Machine will say decrease your withdrawal limit. Decrease your withdrawal limit. Machine will not say that, okay, I have 20,000, so I am giving you 20,000, 1,000 you take next time. No, even if a single rupee is less, your transaction will be aborted. Your transaction will be aborted. Or in the definition of transaction, we don't say quit, exit, failed, aborted. We say your transaction will be rolled back. Your transaction will be rolled back. Rolled back means you got some problem in your transaction and there was something else, so your transaction or is not committing partially. That is known fact that either it will be committed fully or not at all. So here we will say there are two states of transactions. There are two state of a transaction. First is committed state. First is committed state, and second is rolled back state. Anyhow, you might have knowledge about these things from your database only. I am just repeating those concepts. Committed state means committed state means that the transaction has been completed. the transaction has been completed. That is called committed state. Rolled back state means rolled back state refers to the failure in between of transaction. Failure in between of transaction and the transactions and transactions initial state has been recovered. Means whatever your database was in starting, it is coming. For an example, let's understand. We will refer to the same example again. So here SQL will process this query. My database will think that you are processing this query. Insert into student. So database will think that okay, you are trying to insert values. Sorted. Then you are writing values. Means you are providing values now. One. First value will always refer to the first column. ID. It will check. One is there. One is int. ID is also int. I accepted the value. So database has written 1 in the ID column. Second is Shrikar. Then database will check. Okay, you are providing name value, accepted. I want a string. Here in query you are writing a string. So database has written Shrikar also. Then again database is going to third value where again it is expecting the string value only. But you are not providing string value. It will cause an error. So at this particular moment, one error will produce. And when error is producing, in that case, transaction will be rolled back. When encountering an error in the transaction, whenever this error is occurring in the transaction, at that time, when encountering an error in the transaction will be rolled back. Now, actually, I like one thing about programming that it is very declarative. Declarative means nothing is just for its existence. Here, everything has its meaning. Just now I said that in terms of transaction, we don't say that it is a failure, it is a aborted exit. There is a reason that we are saying it rolled back. Now, rolled back means I will write a simple program here. Okay. Java code I will write system.out.println. Here I will write hello world. System dot, or I can write south. You just understand that I am trying to print something. Here I will say I am Shivam. 10 divided by 0. Now if we are checking the output of this code, so the output will come something like this. At first you will get hello world, right? At first you will get hello world. At second you will get I am Shivam. And at third you will get arithmetic exception, right? In the third case you will get arithmetic exception. Now this is a error, or you can say this is a exception. Now in this case, will your compiler remove this hello world and I am Shivam? No. Compiler will say, okay, you are having problem in your third line. What is the issue with previous two line? Let them be there. This is called failure. Failure means Half part is working, half is not working. Failure means half is working, half is not working. Failure means you passed in English, physics, chemistry, but you failed in mathematics. That is called failure. In half of the subject you got passed, but in half you got failed, right? In half you got passed, in half you got failed. That is called failure state. And now when you got an error here, it does not mean that these two things will erase. No, that's why we call it that error. Because of error failure came, because of error exit situation came, because of exit aborted situation came. In all these three situations, program will not erase the good part. But in case of database, insert one accepted, insert as a string Shrikar accepted, then insert Shrikar at the rate of gmail.com rejected. Now when this particular part is rejected, this particular part is rejected, database will reject these two also, that I want all the values or I don't want any value, either fully or not at all. So simply database is saying, if you are trying to give the values, give all the values, no control, or else don't give any value, right? So that is how this is working. And that's why in case of database, we don't say that it is a error. No, we say either it is committed or it is rolled back. In rolled back state refers to the failure in between of transaction and the transaction's initial state has been recovered. Or let me write it in a simple way. So rolled back state refers to the failure. It occurs whenever there is an error in the transaction. Whenever there is an error in the transaction, let us suppose if half values are stored properly but the third value is incorrect, or you can say is invalid, then database will erase the previously stored two values also. That is called rolled back. It will not store those two values. Removed. We don't want that. And this is the example here. So we'll check this. So at first, database will do like this. After encountering the error, after encountering the error, the database will remove the one as ID and Shrikar as name. It will remove that for 110% sure. So what database will do? Database will remove that and it will remove that. And that is your table after the operation. That's why we call it as rollback. That's why we don't say failure. Failure means half are stored, half are not stored. No. Here either there is full control or no control. Right? It's so simple. Either full control or no control. Full control means we will not take any value, or no control means we will take all the values. That's it. And that's why we don't say failure here. We say rolled back. It is the rolled back state. Now, there are some of the properties associated with database. There are some of the properties. We generally call them ACID properties. ACID. You know what is acid? What is acid? Acid. Acid. Array, I am asking what is acid? Acid is a substance, right? Chemical component. What is acid? Tejab. Who is this Hindi person here? Ashok Mishra. Ji Mishra ji. Tejab. You know what is acid? What is acid? Atomicity. Again database. I'm not asking Amal. It's not Amal, it's Aml. Atomicity, consistency, durability. Okay, we are not talking about the acid of chemistry. We are talking about the acid of transaction, not database. Transaction. For maintaining the data consistency and data integrity, there are some of the transaction properties. There are some of the transaction properties. There are some of the transaction properties. We call them as acid properties. Already know, so Srikar will give the definition of all. Okay. A stands for atomicity. Atomicity. C stands for consistency. I stands for isolation. D stands for durability. Yes, A. Yes, sir. What is atomicity? Srikar, sir. What is atomicity? You were singing the song of atomicity, atomicity, atomicity. Now say, what is atomicity? Forgot. Array, just now you were giving answer. How can you forget in 2 minutes? Atomic? Studied in BTech. I also studied in BTech. After that, I have never opened it. I have also studied in BTech only, just like you. Okay. Atomicity means atomicity means all the transaction in the database are treated as a single unit. Now let's try to understand it. You went to bank and you have some cash to deposit. You deposited that cash. At the same time, you realized that you have deposited some extra cash. And now you want to withdraw some cash at the same moment. And then you are withdrawing the cash. Now you have committed two transactions. So there are two Shrikar in the bank, they are committing transaction, right? No, there is only one Shrikar who is committing the transaction. And if Shrikar is failing means all the transaction of Shrikar will fail. So same way here all the transaction in database are treated as a single unit. Till now you have studied this theoretically. Have you practically applied these things? Today we will apply. I don't like theory. Today we will apply this, all the concept, and we will see how it is working. So atomicity means all the transaction in database are treated as a single unit. It means that even if one transaction is failing, even if one transaction is failing, then all other transaction will be failed. Now, transaction never fail will be what? Failed or aborted? Array, if I am giving option, all are wrong. All the transaction will be rolled back. You are performing 4 transaction, 3 completed successfully. When it came to fourth one, error. All are rolled back to their previous state. Today we will see it properly. Okay, so that is called atomicity. Atomicity means the same thing, either full control or no control. Either all values will be stored, either no value will be stored. Then you have consistency. Now, understanding this consistency is actually a bit complex thing. And let me try to give you a complete example. Consistency means you will be consistent. Consistency means, let's say you have a bank account. You have a bank account. This is your bank account. And along with the bank account, you are also having one particular, you can say box, or you can say wallet, where you are keeping the money. Physical wallet. I'm not talking about any digital wallet. Now, transaction is consistent. It means that, let's say, currently in your wallet, the balance in your wallet is 10,000 rupees. The balance in your wallet is 10,000 rupees, and the balance in your bank is around something like this, 7 lakh, right? So this is what your balance is in the bank, and this is in your wallet. Now, what you thought, that you felt like that I don't need 10,000 cash in my wallet. So what you did, you said that minus 5,000 means you have taken 5,000 rupees from your account and you have deposited in the bank. What you have done? You have taken 5,000 cash from your wallet, and then you have deposited in the bank. Deposited in the bank means your bank has plus 5,000 now. Your bank is having plus 5,000 now, like this. Now, consistency means what is your balance here? If you check your balance in the first state, what is your total accumulated balance? Total balance is 7 lakh 10,000, right? Your total balance is 7 lakh 10,000. This is your total balance. You did some transaction here, what you did something, you did something. After that, your balance in bank, after the transaction I'm talking about, after the transaction, your bank is having 7 lakh 5,000 rupees. Your bank is having 7 lakh 5,000 rupees, and your wallet balance is 5,000 rupees after the transaction. Now, consistent means check the total balance after the transaction is made. Now here, if you check total transaction will still come as 7 lakh 10,000 only. This is the one case of consistency, that data is consistent. Second is This is the one example. I am not saying that this is the fully consistency. Now let's first write the definition of consistency. A transaction must a transaction must bring the database from one valid state to another valid state. Now, this is a confusing part. You can understand it like you can understand it by taking example of your car. The basic state of your car is the basic state of car is to stay quiet, or you can say is the basic state of your car is staying state, means it will not move. Then you started your car and drive it for 10 kilometer. You drive in your car for 10 kilometer. In that particular time your car was moving, and then you stopped, and then you stop again. Your car came to the staying state. So the initial and final state of your transaction or your database should be consistent. In starting you were not doing any transaction, there was no change in the transaction. At last when you are stopping, at that time also your transaction should stay silent only, that boss, no movement is allowed. That is called consistency. The next we have is isolation. The next we have is isolation. 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 This isolate term became very popular during COVID. Isolation, isolate. Remember? Or forgot it like BTech only. So this isolation term came very popular during COVID time. My father got COVID actually. So when he got diagnosed with COVID, so it was very rare symptom, like very less, just the starting of it. So doctor advised that you can stay at your home only, no need to be admitted into hospital. Just be isolate in your room. You should stay in your room. You should not go out anywhere. No one should come near you. It means that for 15 days, I remember my father was staying in the room only for 15 days, I think. Uh, we were not going into that room, and he was also not coming out of the room. Just precaution. So that is called isolation. So isolation means concurrent. Nowadays, again, COVID is coming. Isolation means concurrent transaction will not impact each other. Concurrent transaction will not impact each other. Or we can say that the transaction will not interfere into each other. Now, in the same bank, Shankar and Shrikar both went to withdraw the cash or deposit the cash. Now, whatever transactions Shankar is making are related to Shankar only. Shrikar should not say that, why are you depositing 10,000 when I am depositing only 5? You should also deposit 5,000 only. Transaction will not interfere into the each other. The last property is durability. How much durable you are. Means durability means you can consider something like how can I say? how permanently you are storing the values, or any example for it. It means changes are permanent. Durability means that once a transaction once a transaction is committed, means without any error one transaction is committed, the changes made by the transaction are permanently stored are permanently stored. The data will not lost. The data will not lost even in the case of system failure. Even if your system is failing, at that time also your database will not lose the data. It will be there. That is called durability. So this is your transaction, the transaction property, the committed state, the rolled back state. There is one state also, waiting state you can say here, but that I have not written. Committed and rolled back only. Now this is what you are doing. But why we are discussing something related to database? The reason is because we require this in Spring. So we'll go back to our Eclipse now, and we will try to solve one problem. Okay, let's understand. So you can take any example here. Let's take the example of ordering a product online. Okay, you are trying to order a product online, placing an order for laptop. You are ordering a laptop online. Now, what you are doing is there will be a portal where you are filling your name, mobile number, email, and your address, delivery address, right? And then you will be placing order, you will be making payment, and once payment is done, you will get laptop at your desired address. This is the sequence. Now, let's say there is a company. There is a company. There is no login sign up, by the way. Login sign up is not available. You go to website, put your details, order the laptop, make the payment, and you will receive that. Login sign up is not there. So now what you did, you have filled your laptops. Sorry. You have filled your details, your name, your mobile number, your email ID, your address. And due to some payment failure, bank failure, or any failure, you couldn't make the payment. So the company should store your values. No. Your company should store the values. No. Because you haven't made the payment. So why should they store your values? They should not store your values, right? So that is only the case here. We will create this case only. And if I ask you one question, what is the one physically possible property in all these four? Which property is physically possible? All are physically possible. If they are not possible, why we are discussing them? All are physically possible, guys. But there is one property that you have to enable by yourself. That is called atomicity. By default, it is not enabled. Wanna check it? We'll see this. So just try to understand. And all of this I am teaching you just for teaching you one annotation. That is called at the rate of transactional. And it is a highly asked interview question. If you are going for a Java developer position and they are asking related to Spring, they will ask it because it defines a basic way of working with the databases, transactional. Okay, let's understand what it is. So we will create a new project here. Project name we will say placing order, means you are placing the order. Placing order. Lombok MySQL driver Spring Data JPA. Finish. And let's create a database also. We'll create a database. Create database eCart. Something like this you can create. Okay. So we have the project here, placing order, where it is here. We will just add the quick things into it. All these data source properties we'll just copy paste into our project. Database name is eCart this time. And we will create all the packages. Now, I think I can do that fast and without telling you that how many packages we need here. At first, we need a entity package. Second, repository package. Third, service package. Third, service package. Fourth, implementation package. However, these two are not mandatory, but for a safe side. In entity, you will save you will have a class of customer, class of customer. Okay, we'll see class of customer. Now, what we will do in this customer class, this we are taking four values or mobile number we can make as primary key. So private string name, private string mobile number, it is our ID. Private string email and private string address. Okay, so these are the things that we have written here. Quickly we will do the things. I want table of this class. I want Spring to manage its object. I want getter setters like this. Okay, sorted. I will have one table also. That table will say orders so that the database administrator can check that how many orders we got today, right? Like that, day wise. So here order will be an entity. and it will be a component, and here order ID, private int ID. It will be our primary key. There is a auto generation strategy as well, but that I will teach you later. Private string uh, order a product. What is the product? What is the product and at what address we need to deliver that? Simple. ID, product and address. That at this address we need to deliver this product. Sorted? Now at the rate of data as well. We will quickly execute the main application. You can say application context container equals to spring application dot run. So here we have got two tables. Okay, sorted. Now create their repository as well. So in the repo package, we have to create an interface. Customer repo. It, and same way we will create pro order repo. It will extend JPA repository. Type is orders, orders, and primary key is integer. Okay, like this. And customer will also extends the JPA repository with the type customer string is the primary key. Now in the service package, I will create a interface. Order service, order service. What I will do? Order service interface, and it is having one method. It is having one method. What kind of method? So it is having one method as public void create order. Public void create order, and it will accept, what it will accept? One customer value. It will accept one customer value that to this customer, and let's say this website is only delivering laptop, so product is by default laptop only. So in the order class I will remove this product, will remove this website is only delivering product, we don't need anything. Now we'll go back, we'll start the application again. So like this we will do. In the implementation package, now we will create a class. Class is order service implementation class. Now it should implement the interface, that is order service interface. Now if you are implementing the interface, we have to override their methods. Now sorted. Now I will do something here. At first you are taking one customer, right? You are taking one customer. So you will save this customer or not? You will save. For saving the customer, you need and here I will override auto wire that. What I will do, I will auto wire the object of private customer repo cr, like this. Okay, and what we will do here, we will say cr dot save c. Can I say this, that save the customer? After saving the customer in the database, check if payment is coming or not. Payment should be the main thing, right? If payment is coming or not. In the service package, we don't have any class, but I am directly creating one payment service class. Payment service class. Now this class is having one public boolean check payment method. Generally you have to implement the things, right? But which is directly returning false, means payment is not completed. By default I am giving this value that payment is not completed, so return false. Now this order implementation has saved the customer in the database. After that, this payment service I will keep at the rate of service here, so that I can auto wire that. So I will say at the rate of auto wired private payment service PS, like this I will say. After checking the after checking the order, I will check if PS dot check payment, it returns true and false. So directly I can write PS dot check payment. In the if I can write or not, because it is returning boolean value and boolean value can be true or false. So I am writing if it is returning true, then I will save the orders. I will save the order. So I need the object of order repository. So that also I will auto wired private order repo or order repo or. And here I will prepare one order, that is order O equals to new order, or just like this you can consider. You have to import its package orders. It says orders, not order. Orders O equals to new orders. ID and all those you can give. So here I will say order dot set ID. Order dot set ID. Now we will create any random ID, let's say 10, and address. So O dot set address. From where we will get this address? From customer C, this one. So here I will write C dot get address, like this. Now this is the if condition. Else if payment is not getting completely, then I will throw new exception. Here you can throw one new exception, but let's say here we will create one own exception that sys out divided by 10, 10 divided by 0. Now it is a exception here. It is a exception. Now we will go to the main class, and here at first I will create one customer. At first I will create one customer. So customer C1 equals to container dot get bean customer dot class. C1 dot set name, let's say Shrikar, C1 dot set mobile number, string only we have provided, so 9 something like this. C1 dot set email, email is also string, Shrikar at the rate of gmail.com. C1 dot set address, ABC Street, KPHP, Hyderabad. This is the address. Now, there is one order service implementation class. We need its object now. So we will ask to the container only. Order service implementation class OSI is equals to container dot get bean order service implementation dot class, and I will call OSI dot create order on the customer C1. Simple thing, I am saving two values. Let's start the program now. And program will end with the exception. Right? So here the program has been ended with the exception. Right? Now what I will do inside this particular scenario, let's check our database. Use eCart, show tables. How many tables we have? One customer table and one order table. Select asterisk from orders. Is there any order available? No, because payment is returning false. Order is not created. Select asterisk from customer. Then why we have one customer's data here? Huh? We can handle the exception by writing close, throws. Did you understood what I'm saying? Okay. You know, actually, I am not talking about exception. Here, intentionally, I am creating one exception. I am dividing z by 0. I know that this is the exception. And this exception is arising because this else is working. And why this else is working? Because payment is returning false. That till now you haven't made the payment. So where is the atomicity here? Where is the atomicity? Customer has not or made the payment. Then why are we storing the customer's data? We should not store the customer data. That is the issue. So let's try to, I will delete the customer table. Drop table customer. Okay. And again, we will execute. This is the address of customer. When customer is not making the payment, why customer data is going into database? It should not go, right? Whenever you are executing this create order method, half working, half not working. But this is not the property of database, right? That half transaction is working, half is not working. Either full transaction should work or not at all. Here again, if we will check, select asterisk from customer data we are getting. But if we check the data in order class, there order table, there is empty set. Is atomicity being followed here? No. Atomicity is not being followed here. Why? Same method is storing two values. Now, let's say the payment service is saying that yes, payment is true. Payment is true. means customer has made the payment. We will execute the class again. So here now we will check the tables. Order table is still empty. Why? Okay, we are not saving the order. So order repository or dot save o. We'll execute it again. Okay, we will check the order table this time. There is a order ID 10 and we have to deliver laptop to this address kphp. Am I audible now? Okay. We just had an electricity failure here. So what we have seen here, now order is also coming. And now if customer is coming, we don't have any problem, right? So here if you can see, we are getting orders. Wait, you will also see in 2 minutes. See now. Here you are getting order as well as customer. Now it is fine that okay, this customer Srikar with the mobile number, with this email ID, with this address has placed an order. That is fine, right? Now we will delete the tables and the payment service By the way, it will come from a server. Google Pay, Phone Pay, generally Razor Pay we implement. False. Payment is false. And in this time, do you need to store the value? Answer is no. We don't need to store the values of customer. If customer is not making the payment, why we can say inside if condition we can save the customer, because after payment we can save the customer. It is just a situation that I am making here. I am not saying that okay, well, you will do this. In case you want to save the value, you have to save the data, right? It is just a situation. Don't give me the solution for this situation. Understand what I am teaching here. So here we are saying that we are trying to save the customer's data. Then we are checking the payment service. If payment is done, then we will create the order, or else we are just throwing an exception. Now, in this way, you can throw a particular exception here. You can throw a runtime exception here like this. Simple. That if you are getting any payment, create the order, or else throw the runtime exception. Now we know that customer is not making the payment. So here we got one runtime exception. Actually, you can throw it by using class. If we check the order table, there is no order. But if we check the customer table, customer data is available there. Why? This customer has not made the payment. Then why we are storing this particular data? Now here atomicity is not there. Half transaction is working. Half transaction is working. That is only handled by at the rate of transactional annotation. Spring is very good because it will give you one annotation for handling the entire situation. Let's see how it will work. So what is this transactional? Here we'll say in Spring framework, or more specifically we can say that in Spring Data JPA we have one annotation that is transactional. Remember it, don't forget it. It's very important. This one transactional. Why it is used? It is used to manage the transaction. It is used to manage the transaction atomicity. Why it is used? It is used to manage the transaction atomicity, and atomicity just now we have seen either full control or no control. Either all the values will be stored or not even a single value will be stored. So it will tell Spring, it will tell Spring that the method that it will tell the Spring that the method should execute fully or not at all. Let's take an example. I will keep the same code of transaction here, placing the order, this one, this particular class. Now in this class, if payment is failing due to any issue, then also the customer data, then also the customer data will be stored into the table, which is breaking the atomicity property. If there is any exception occurring in between the transaction, then the transaction should be rolled back to the previous state. It means that it should erase the values of customer that are already saved in the database. So that is what it will do. Now let's try to keep one annotation here. Over this create order method, I will create a annotation that is at the rate of transactional. But I will create at the rate of transactional like this. And what we will do, we will drop the customer table, drop table customer and drop table orders. So both the tables we have dropped, and again we will start the application. And here it is throwing the runtime exception. Shall we check the database now? We'll go back. We will check the database. So tables created, select asterisk from orders, empty set, select asterisk from customer, empty set. Arey, why customer is empty? We are saving the customer value. Yes, we are saving. Here we are doing cr dot in the order service implementation. We are saving the customer, but it's not working. The reason transactional is written here. It will maintain the atomicity of the transaction. If you are getting any exception, any error in between till end, rolled back, it will be rolling back because previously it has stored the customer value. It will delete that, or you can say it will not even store that, removed, rolled back to the previous state. Now we will add the at the rate of transactional annotation over the method to implement atomicity like this. Now in this case, as the payment service will throw a runtime exception, so the customer values will also not be stored in the database as the transaction will be rolled back. Okay, as the transaction will be rolled back. This is called your at the rate of transactional annotation, and that is called atomicity. That half part is working and half is not working. Half is working, half is not working. So that's all. Transactional is far more here. We'll see transactional tomorrow also, because here we have some of the propagation level, and tomorrow we will finish the Spring JDBC, or you can say the Spring JPA, or you can say ORM module. Tomorrow completed. Some theory topics are there. We will discuss them and sorted. Actually, pagination and sorting is there, but without the knowledge of front end, you can't implement it. So I will give the theory now and implementation when you know the front end. Okay. So that is your transactional. Any doubt, any issue in this transactional annotation? Now understood? Am I doing any arithmetic exception here, sir? Huh. Any exception is coming. Any. Any unchecked exception. Because checked will be visible here only. But if any unchecked exception is coming, at that time, this transaction will be rolled back. Rolled back means half value is stored. Now, one complete table is already stored. Customer table is different. Order table is different. Customer table is already stored one customer value, but that is also rolled back. If there are 100 tables that are storing data on one transaction and you got a problem in 101 transaction rolled back, all the data will be lost, rolled back state. Okay. And it is the with regarding to the interview point of view, transactional is important. They can ask you to implement the service, copy paste the same thing there. If you are doing same thing, if they are asking you to do it in 1 hour, you can do it in 20 minutes, right? Just do it quickly, implement the same thing, order, payment, customer, like this. Okay. I'll give you the notes and the zip file. How can the transaction know the transaction is failed? Array man, here you are throwing runtime exception, right? The transaction will check the create order method is exiting with a 0 or is it throwing any exception. If it is throwing any exception, at that time the database will know that okay, now it's time to go back, rolled back. Tomorrow also we will see this thing, don't worry. Okay, fine guys, we'll connect again tomorrow. Bye bye, take care.